In addition to having a query ID and randomization of that ID, the resolver can randomize the source port on which it sends the query, thereby adding an additional 16 bits of entropy to the ID that's associated with the query. Unfortunately, picking a random source port can be resource intensive, and also a network address translator, or a NAT, could de-randomize the port. Another defense is called the OX20 or 0x20 encoding, which is based on the intuition that DNS matching and resolution is entirely case insensitive. So capitalization of individual letters in the domain name do not affect the answer that the resolver will return. This 0x20 bit, or the bit that affects whether a particular character is capitalized or in lowercase, can also be used to introduce additional entropy. When generating a response to a query, such as this one, the query is copied from the DNS query into the response exactly as it was in the query. The mixed pattern of upper and lowercase letters thus constitutes a channel. If the resolver and the authoritative server can agree on a shared key, then the resolver and the authoritative are the only ones who know the appropriate pattern of upper and lowercase letters for a particular domain name. Because no attacker would know the appropriate combination of upper and lowercase letters for a particular domain, it becomes even more difficult for the attacker to inject a bogus reply, because not only would the attacker have to guess the ID, but the attacker would also have to guess the capitalization sequence for any particular domain name.